The St. Lawrence is an enormous system that has undergone countless structural changes since the 19th century. Most of Quebec's population lives in the St. Lawrence River Valley and is concerned about river management.
Our top concern for the entire territory we have here is what we call coastal hazards, which encompasses everything concerning the erosion of the banks and the swallowing up of land by the St. Lawrence.
While some people want the water levels to be stable, others maintain that fluctuations play an important role. After the sizable Moses Saunders hydroelectric station was built in Cornwall, the International Joint Commission set up an organization to oversee the management of the St. Lawrence water level.
The International St. Lawrence River Board of Control is part of the International Joint Commission, a binational organization, Canadian and American, that manages the waters that mark the boundaries between these two countries.
In the past, spring runoff of the Great Lakes and the Ottawa River caused major fluctuations in the water level, which resulted in flooding in several places. The construction of the Moses Saunders Dam, originally designed for hydroelectric production and commercial navigation, allowed the St. Lawrence water level to be better managed while taking into account the needs of different interest groups.
One of the important aspects that we take very seriously is civil safety. In other words, in making decisions, we'll take into account the fact that there may be major spring runoff in certain parts of the river at times. So we'll reduce the water level upstream to ensure there's no flooding in Montreal, for example, or elsewhere during spring runoff.
Environment Canada's role on the International St. Lawrence River Board of Control consists of providing environmental forecasting services in compliance with orders from the International Joint Commission. These forecasts, produced by digital modeling, make it possible to simulate the St. Lawrence's evolution.
We use absolutely all the observations that exist in the environment: air temperature, humidity, precipitation, water temperature. Absolutely all the variables used to create the initial conditions are incorporated into the models. Once we have that, we can initiate and do a complete environmental forecast.
Modeling allows us to predict fluctuations in the water levels and flows, for example, as well as temperature and water quality variations, ice flow, the breadth of marshes and swamps, changes in fish populations, and how far agricultural or municipal pollutants spread.
Integrated modeling tools help us respond to complex issues, such as regulating the Lake Ontario-St. Lawrence system, evaluating the impact of contaminants on the river's ecosystem, and responding to environmental emergencies that involve the spilling of floating or soluble pollutants. The development of the environmental forecasting system has been very important. It allows us to better understand the St. Lawrence and to better manage it. The St. Lawrence ecosystem is one of the most amazing ecosystems in Canada. It's the ecological lungs of Quebec and contains a tremendous, rich diversity. It has urban environments as well as environments that are still very wild. It's an ecosystem that we need to learn to appreciate and to benefit from. But we also need to learn to protect it and to preserve it for future generations.